Hi, I'm Brian Laborde, and I'm here to talk to you about Frontier Design Automation's new AI-powered IC router. I've been in the EDA world for over 30 years, and I spent the last 18 at Cadence Design Systems. I started as a virtuoso application engineer and spent the last few years in product management, but most of my Cadence career was spent as a product engineer for the analog and mixed signal routing products. So I've used, tested, and supported all sorts of auto routers. When the guys at Frontier Design Automation showed me what they wanted to bring to market, I knew I was looking at something truly special, something completely different than the industry's ever seen. But first things first, who is Frontier Design Automation? Ed Gernert and John Cooper are industry veterans in shape-based routing. If you've done any mixed signal IC design work in the last few decades, you've probably used one of their routers. Their first generation shape-based router was known as IC Craftsman and became a fast favorite of many custom IC designers as part of the Cadence offering. And it's still in use at many IC design houses today. Their second generation router, known as TerraRoute, became part of Magma's mixed signal flow, and then Synopsys adopted it as well, and then acquired the company in 2009. In 2019, Ed and John set out to create a third generation shape-based routing architecture that was not just a retuning of decades-old algorithms, but represented something fundamentally new and different. Ed and John are well known in the industry and partnered with all the right folks to bring their vision to life. A colleague of ours from EDA became an AI consultant in 2015, and he provided AI architecture to drive their innovation. Recently, Jack Wild and I joined, bringing decades of layout experience to the party. We partnered with big names in the industry to help forge ahead as well. Frontier is an SI2 member, as you can probably guess. And if you've heard the name before, it's probably because we presented 3 times before at their annual open forum. Also, we're a member of the Siemens Software and Technology Program, which, among other things, allowed us to validate our routing results with Calibre DRC. When they set out to create their router, Ed and John decided to do a few things in a fundamentally different way. First and foremost, they wanted to use emerging AI technology. Remember, this was 2019, or in the before times, as my kids like to say. They're probably referring to COVID, but in 2019, AI was also not the household topic that it is today. Ed and John were ahead of their time. They saw the potential to provide a simplified use model, one that would just plain do the right thing without a lot of settings, data prep, or other time-consuming and frustrating work that required experience and patience. But also, they envisioned bringing AI to bear on the mechanics of the routing problem to make results better and faster to come by. In auto routing, the database and routing algorithms are innately intertwined, so these experienced router architects went to work on the database first and reimagined how to store data in a way most conducive to their routing vision. This new database structure they came up with was novel enough to merit a patent in and of itself. Finally, no stone was left unturned when it came to the routing flow. They questioned the need for steps that are considered standard, such as starting with a global route. The old standby of global, local, detail steps were thrown out, and a new flow was devised to tackle auto routing. Now we start with a quick route that typically completes 95 to 99% of a million net design in just a few minutes. To complete the remainder, other strategies are employed, such as Global Assist, that does something akin to a global route, but only for a handful of nets that need it. Building a completely shape-based router, different than anything on the market today, started with a new, innovative database. It should come as no surprise that we built the Frontier router with SI2's open access in mind. In today's EDA world, flows and tools are largely centered around OA, so we found it essential to validate our full bidirectional interaction with the open access database. The foundation of our router needed to accommodate the growing capacity of today's designs. It also needed to handle many cores simultaneously writing to the database. Ed and John created something so innovative that we filed a patent on the technology. Without going into too much gory detail, typical routers use a bin structure, where there are many bins on each layer, and a single large shape might be enclosed in hundreds of bins. Each bin requires storage and a pointer to each shape within the bin. Frontier uses a map structure built such that any shape will only fit into one map slot. Searching is much faster, since we only look at one slot for the area in question, and memory requirements are drastically reduced, since the shape only exists in one place and no pointers are required. Threading is achieved by locking a slot at the lowest level without affecting any other area being searched. This was the beginning of a new generation of shape-based router that's 100 times faster and 1,000 times the capacity of a traditional shape-based architecture. In our capacity testing, we've loaded 56 million net layout with 186 million connections on a common desktop workstation. And now, the moment you've all been waiting for. Let's talk about AI. I can't expose exactly where and how we've applied AI to the routing problem because it's our secret sauce. And unlike the database, we have yet to file the relevant patents. But I can talk at a high level about what kind of AI we use and why. As you know, there are many incarnations of AI. We settled on unsupervised learning because it takes raw, unstructured data and uncovers hidden patterns all by itself. Unsupervised learning is all about discovery. It sifts through complex designs and finds structures or relationships that we might not even know to look for. It can identify a group of wires following a similar path without needing to understand what a bus actually is, allowing the router to create routes like a human would. Unsupervised learning avoids the time-consuming training process where you would provide previous design data for it to learn from. You just point it at your data and it starts working immediately, saving precious time and resources, freeing them up for other tasks. Other than saving time spent on the training task, the elimination of the training process safeguards your proprietary information. Since it only works on the data you provide and doesn't store its impressions, there's no risk of exposing sensitive intellectual property from previous designs. And it isn't studying or storing your unique design style. This makes it ideal for an industry like ours, where data security is critical. The applications for unsupervised learning are vast, from partitioning groups of nets to detecting patterns in layout, making routing decisions like a person would. Unsupervised learning is incredibly versatile. It finds application in all sorts of places in the routing flow. Finally, this approach shines when handling large data sets. Unsupervised learning scales effortlessly, delivering insights no matter the size or complexity of the data at hand. Every router I've used in 3 decades of EDA have employed some variation on the same formula. Global route, track assignment, or some call it conduit route, and then finally a detail route step. Global route is used to dice up the routing problem, to limit the search space required by poor aging algorithms. This breaks continuity at the intersection of G cells, which creates unnecessary bends and jogs and extra vias. And more importantly, all that drastic partitioning squanders overall resource consumption and hinders performance. Due to our advanced database and the use of unsupervised learning AI, we can create long routes in one phase and guarantee cleaner, straighter connections. As I mentioned, Quick Route completes most of the routing in minutes on very large designs, and in seconds on smaller ones. Then, when completing the handful of remaining routes, our innovative Global Assist is sometimes called on a pin-to-pin connection, but only when the smart algorithms detect that would be helpful. It sees all the obstructions in the design, and it can create a new solution on the fly. All this may sound complex, but it's important to understand that it's done automatically, with no user input. Most design teams I've worked with had a routing expert that knows which router to use for a given design style, or at least all the settings and tricks to get the result that they want from the router they have. We've eliminated the need for all that expertise and apply the most appropriate algorithms automatically, allowing for push-button operation that any designer can use right out of the box. So far, we talked about how we leverage AI and our advanced database to parallel process large designs rapidly. But I'd like to delve into the nitty-gritty for a moment. We're currently working on robust integration into popular design tools, but we also have a complete standalone GUI. We redesigned it recently in Qt to provide a clean, intuitive interface that visualizes your routing progress in real time. You can see net connections, DRC violations, or congestion hotspots instantly, making it easier to debug and optimize your layout. Compatibility is key, and our router supports both Linux and Windows environments. Whether your team runs on Linux for high-performance computing or prefers Windows for integration with RF and photonics tools, our router fits seamlessly into your workflow. Here's something every designer will appreciate. We have no bug backlog. We pride ourselves in resolving every reported issue immediately. That means no delays from unresolved issues holding up your design cycle. Frontier provides a reliable tool you can count on for mission-critical projects. Finally, our clean code base makes feature addition a breeze. Need to support complex shielding constraints or that wacky new design rule? We've got you covered. Thank you for allowing us to introduce you to Frontier's AI-powered IC router. Please visit our website for more info. There you can contact us and arrange a deeper dive. Let's meet one-on-one so we can show you how the router works on a variety of layout styles and share performance benchmarks. We want to hear about your design challenges and how we can get you to tape out faster and with less headaches. Many thanks to the fine folks at SI2 for giving us this opportunity to present. We at Frontier truly appreciate it. While we couldn't be there in person, Ed and I are available to answer any questions you have. We'll run a brief video demo in the background while we take your questions. So please make note of our URL, frontierrouter.com.